Today we're going to learn how to set and read micropipettes. In our class before, we've used the plastic pipetters that are kind of like eyedroppers. We also had the ones that were green and they had the little wheel that we had to use to suck the liquid up and down. The micropipettes that we're using today are different. They measure micro amounts. We're going to be working with DNA and bacteria, which are really teeny tiny. So we're going to be using pipettes that are very accurate at reading small amounts of volumes. So micropipettes come in 3 different sizes. You can see them over here on the right. If you look at the barrels, you can see that they're shaped differently. The one on the left actually measures the smallest amount, the one in the middle the medium amount, and the one on the right the highest amount. If you notice, it's a little hard to read with the glare, but all 3 of these pipettes say set 1, number 8. So these 3 pipettes are going to be used by table 8. There's another set of pipettes that are going to be used at table 8. They're number 18. So if you're at table 2, you're going to have 2 or 12. If you're at table 4, you're going to have 4 or 14. Now, when you're looking at these pipettes, if you look up at the top, there are little buttons, or like the plunger part. When you're looking at the plunger part of the pipette, you're going to see that they are different colors, as well as they have some different numbers on them. This one here is the smallest pipette. It measures from 2 to 20 microliters. The unit for microliters kind of looks like a lowercase u, but it has this extra tail on the front of it. The medium-sized pipette measures from 20 to 200 microliters, and the largest one from 100 to 1,000 microliters. Now, microliters, if you're thinking about like what a liter is, think of a 2-liter soda bottle. Then you guys are familiar with measuring in milliliters in our class. We're going to be using microliters. Microliters, you're going to have to move the decimal 3 times over from going from milliliters to microliters. So it's pretty tiny, tiny amounts. Now, you can actually measure, if you look at the medium size and the large one, you can, if you needed to measure 130 microliters, you could use either pipette. So there is some overlap between these two. In your notebook, in the packet, you'll see this page. And here it says it goes from 2 to 20, smallest amount, etc. Okay, well, these pipettes have names. And the pipettes are named P20 for the first one, the smallest one, where P stands for pipette, and the 20 is the highest amount that it can measure. The medium-sized one is a P200, and the largest one is a P1000. And when you're looking at these pipettes, when you need to dial the amount that you want to pick up, there are actually on the side of the pipette little windows. And these windows all have 3 digits in them. You can also notice that the one on the left the P20 has a red number down at the bottom, the 6 in this case. There are no red numbers on a P200. And there is a red number on the P1000 up at the top. Now, each of these windows, each of the digits in each of these windows all have different place values. All right, so think back to when you were younger in maybe elementary school or middle school, you learned about place values. If we have this number 1,345.2, think about which place the numbers are in. The 5 is in the ones place, the 4 is in the tens place, the 3 is in the hundreds place, and the 1 is in the thousands place. And this 2 is in the tenths place, or the 0.01s. Now, if you look over here, we have it's showing you what numbers are in these different place values. So 13.6, the 1 is in the tens place, the 3 is in the ones place, and the 6 is in the tenths place. So you can kind of imagine with this red number here that there's a line drawn right here. And that line represents a decimal. So this number here would be set at 13.6. In this sample right here, we have 0 to 0.0. The P200s, what you see is what you get. There are no red numbers, so there's no special like decimal or anything like that. So on this sample here in the middle picture, we have 198, where the top number is the hundreds place, the middle number is the tens place, the bottom number is the ones place. So on this example, we have 44. 044 would be 44 microliters. Now on our P1000, the top number is also red. This time it's not a decimal. This time what this represents is a comma. So the top number is the thousands, the middle number is the hundreds, the bottom number is the tens. We don't have the ones place. The ones place isn't showing, so that would be like a 0 in the ones place. So this number would actually be 0,950 down here, so it's 950. This sample here, if we have 1,00, it reads as 1,000. If we wanted to do 350, we'd have a 0 in the top box, comma, 3, 5, and 0 in the non-existent box. Okay, so that's how you're going to set and read the pipettes. It's really important to make sure you're using the correct pipette, so always check the top and make sure that your number fits within the range that this pipette can measure. But then look at the numbers and pay attention especially to the red numbers, or if there's not a red number, because then that's going to help give you a clue. In your box when we're doing this lab, you'll always see this kind of cheat sheet here on the left that will help you out. Now, what you're going to do on this page, okay, what it's telling you up top is we have this is what the button looks like on the top of the pipette, and it gives you the range. What I'd like for you to do here in this box, I'd like you to draw a red line right across here where we have the, right there. Draw a line there and then put a period for a decimal point. On the P1000, we also have a red number up at the top, so draw a red line up at the top and draw in a comma. That's going to help you remember what's what. Then in the boxes, you're going to write which place value this is. So tens, ones, here's our line with our decimal, so this is the tenths place, or the 0.1s. And then the range, this one goes from 2 to 20, so you're going to write that down. And you're going to do the same thing for the P200 and the P1000. Then you're going to have a chance to practice which pipette you would use to measure each of the following volumes and writing down how many microliters the pipette is dialed to. And there are a few mistakes in here that you're going to see and you're going to be like, that doesn't make any sense. You can't do that with that pipette. Those are there on purpose. I want you to really pay attention to what you're seeing in these pipettes. And when you do find a mistake, you can edit it. You can change this number if you need to. You can change the pipette if that's what's wrong. You can change these numbers. But I want you to edit it to make it so that it will make sense. And I'm going to show you how to do the first few. So over here on the left, if we have to measure 10 microliters, we need to think about which pipette we're going to use. So we need to make sure it fits within the range of the pipette. If we look back up at the top, 10 microliters would fit between 2 and 20. It doesn't fit between 20 and 200 or 100 and 1,000. So we're going to use this pipette, the P20. So I'm going to write P20 up here. But I want to double check to make sure that the numbers are actually dialed correctly. So if we needed to measure 10 microliters, remember that on a P20, there's a red line that represents the decimal right here. So 10.0, that's 10. So this one's good. Our answer is a P20. The second one here, we need to measure 100 microliters. Now, remember, if you need to measure 100 microliters, there are two different pipettes that you can use. 100 falls within the range of the P200 as well as the range in the P1000. So we need to really think about which one is showing us the correct answer here. So if we were using the P1000, remember that the top number is red, so it would be a comma there. So if we had 1,00, an extra 0 in the non-existent window, that would actually read 1,000. So this is not a P1000. So let's try it with a P200. P200, what you see in the windows is what you get. So I see 100, that's 100. So our answer is correct up here. It's a P200. Down at the bottom, when you start, you have more to do. So you have a P20, 12.0 microliters. So if you're using a P20, red numbers at the bottom, so there's a decimal place here. So you write in 1, 2, 0 for 12.0. For these ones over here, you have to say both the pipette as well as fill out the numbers. So go ahead and fill these out, and if you get stuck, you can ask in class. Now, there are 4 rules for pipetting, and you need to take these in your notes in your packet. There's a page for pipetting rules. The first rule is you always need to hold the pipette in the upright position. So what that means is you need to hold it like you see right here, upright, not sideways, not upside down. We can store them when they're on the side when we're not using them, but once you put a tip on them, you'll see a tip in a minute. It's in this picture here. Once you put a tip on them, you need to hold them upright because these pipettes are really easy to damage. If liquid gets into this white part, this barrel part, it will make it so it can't accurately record or pick up the right amount of volume, the right amount of liquid, and it will damage the pipette. So we don't want any liquid if we put it on its side or hold the pipette upside down touching the barrel. Now you also never want a pipette without a tip on. So the tips are these guys at the bottom, and basically that's where the liquid goes so that it doesn't touch the barrel. And you're never going to use the same tip twice. We don't want to contaminate our samples. If we take DNA from one tube and put it into a tube that has some other liquid in, and then we put that same tip back into the DNA, we just contaminated our DNA. So you're never going to use the same tip twice. All right, and rule number 4, you always want to keep your eyes on the tip. You want to hold your reaction tube at eye level. So I'm going to put a tip on our pipette. And if I'm pipetting and I'm holding it down below where I can't really see it, what might happen is if there was liquid in here, if I was sucking up liquid into the tip, the level of the liquid in the tube is going to go down. If I'm not watching carefully, I might be sucking up liquid, but then end up sucking up air because the surface, the top layer of the liquid went down. So you really want to be careful and watch what you're doing. So you're going to hold it up at eye level so you can really see what it is you're doing. And one thing that kind of tricks people up is that sometimes it can be hard to open and close the reaction tubes, especially the smaller ones like I have right here with one hand. And so it can be a little awkward. And what some people will do is they will have their partner open the tube for them, which is awesome. It's great teamwork. But if you're now reaching over and trying to pipette with the tube that your partner's holding, you can't really see what you're doing. So you always want to pipette by holding it and watching what you're doing, keeping it at eye level. Now, in our labs, we're also going to be centrifuging. So what might happen is when we're putting small amounts of liquid into our little tubes, you might get little drops stuck to the side of the tube. And we need to pull them all together down at the bottom of the reaction tube. So we're going to use a tool that you see here on the right called a centrifuge. And for the centrifuge, you need to make sure your tubes are tightly closed. You want to keep the centrifuge balanced. This is going to spin really, really fast. And think about your washing machine. If you've ever had all the clothes like on one side of the machine, when it will make the washing machine unbalanced and it will start rocking and making an awful noise because it can't spin properly when it's not balanced. That happens with the centrifuge as well. So to keep this balanced, if I had 6 tubes with all the same amount of liquid in them, that would be balanced. But there are going to be times when you're only working with 2 tubes. So if I put one tube up here, to balance it, I would need to put the second tube directly across from it. And that would mean that it would be balanced. If I had 3 tubes, I would do it a little differently. I'd have one here, and then I'd go every other one, and that would be balanced. If I had 4 tubes, that one you can still do. You can still balance that. If I had one over here, I'd have the opposite here, number 2. Then I could have 3 right next to it. The 4th one needs to be opposite of that, though, so right here. If I had 5, that unfortunately wouldn't work. It would not be balanced if I filled up these 5. So what I would need to do is maybe do 4 at a time and then let them spin. And they're going to spin for about 30 seconds, or sorry, 3 or 4 seconds. And then when they're done, I can take out 3 of them, keep one in. That one can be spun twice and put the new one in across from it. Now, how this works, once you get them in the centrifuge tubes, in the holes, you're going to close the lid, and it's going to like press and lock into place, and it's going to automatically start spinning. You're going to wait till it gets to full speed, and then just count to 4. And then you're going to open it by just pressing down right here. It will kind of unlatch the lid. You might have to pull the lid open a tiny bit, but don't open the lid all the way like you see it here until it stops spinning completely. You don't want to get your hair stuck in it or sleeve. You don't want to reach in too fast and like pull your fingernail off. So be really careful with the centrifuge. And if you hear it make like a loud noise and it's kind of like a squealing, whistling noise, it's not balanced, stop what you're doing because you can break the centrifuge, and you need to make sure that you put them in the correct spots, or that you have the right amount of liquid in each of the tubes. If you have one tube that's totally full and one tube that's half full, that's going to not be balanced. The tubes need to have the same amount of liquid in them.